My topic is titled Circular Design and Sustainable Manufacture of Permanent Magnet Machine Components. This is for permanent magnet electrical machines, which I'll refer to as PMEMs for short. For me, the main areas of research so far have been: what are PMEMs and why are they important? What is the current life cycle of PMEM components? And why is sustainability important within this sector? What is sustainable manufacturing and the circular economy? I'll give a brief summary of each before moving on to the future for this research topic. Please forgive me if I'm telling you something that you already know. PMEMs are a type of electrical machine which acts as a motor or generator depending on the application. They're used in many different products, but this research will look primarily at products critical for future electrification, such as in electric transportation and in wind turbines. These two sectors are set to increase in the coming years, making the life cycles of PMEMs even more important. There are many components within a PMEM, as well as fixings, adhesives, and so on, but I'll be going forward concentrating primarily on the active components of the electrical machine: the stator, rotor, coils, and magnet. These components can require up to 22 different elements extracted from the earth within their manufacture, and each face many of the same issues, which were uncovered in part 2 of the research. What is the current life cycle for PMEM components? Looking at the life of the PMEM, it is a typical cradle-to-grave linear process. This comes with its own issues almost all the way from birth to death of the machine. I viewed these with a consideration towards sustainability. Firstly, the machine is not generally designed with the end of its life in mind: how to repair it, how to easily replace parts, or how to recover the materials. Typically, the materials used are metal alloys sourced from different mines worldwide. Mining can be very damaging to the local environment, and once a mine is depleted, it can be difficult to return that land to its original state, as demonstrated here in this image of Bingham Mine in the USA. From here, the ore requires refining. This is an example diagram, but I think it demonstrates quite well how extensive the processing required can be just to separate the desired materials from the ore that is mined, often with many steps which may be accomplished at great heat, in vacuums, or with chemicals. The leftovers are most likely then discarded. These photos were taken 5 years ago at the man-made toxic lake in Bayanova, China. It is an extensive area in which up to 45% of the world's rare earth elements are mined from, as well as over 1 billion tons of iron. Neodymium found in permanent magnets is often sourced from here. To then make actual product components from these individual metals again requires multiple manufacturing steps. These components then need assembled and transported worldwide to the required locations. The products are typically used for an approximate 8-year service in a car and 20 in a turbine. At the end of their life, the lack of foresight at the design stage makes these challenging to disassemble, which can result in the machines then being considered as waste. I feel this process answered half of part 3, why is sustainability important to PMEMs? By putting this process at the forefront of our minds, we can see that the manufacture of these machines has an obvious, quite extensive impact on the environment, which we are not generally privy to. Ultimately, the drivers for sustainability in this area should be to make the sustainable products sustainably. By that I mean the goal for us, almost globally, is to move forward into a future where we run on electricity, produced not from finite materials from the earth in the form of fossil fuels or coal, but instead by harnessing the power of the wind, the sun, and the tides. The issue is that we are using finite material from the earth to create the products in order for us to stop performing the exact same action with fossil fuels. It is oxymoronic and demonstrates perhaps that this sudden drive to push this newer technology forward hasn't been thoroughly thought out. The reason for the drive to electrification is because various countries are pushing forward with energy targets, carbon targets, sustainability targets, and so on. The UK has the Climate Change Act 2008, and Scotland subsequently has the Climate Change Act 2019, which is full of, as the government states, ambitious targets. It even states that our contribution to climate change will end definitively within 1 generation. In theory, it sounds great, but it essentially means we're pushing ahead with things like electrification at a fairly substantial rate in order to reach these targets that we've self-imposed. The problem with this, though, is that whilst we here in Scotland and indeed the UK will soon benefit from the products themselves if we don't already, the carbon footprint from the manufacturer doesn't count towards our targets because they are not made to. This is known as consumption emissions, and it is possible that Western countries are more likely to achieve, or at least come closer to achieving, their sustainability targets due to the lower levels of mining and manufacture in these countries. This essentially is putting the ball in someone else's court, even though we will also ultimately feel the effect. A review of current literature reveals that there has been success in remanufacturing and recycling permanent magnets, in particular, from materials reclaimed from waste products. This is an area I'm still researching and hope to conclude by the end of 2020. However, in order to be truly sustainable, we must aim to do better and reduce the waste almost entirely, which leads us on to the circular economy. Circular economy is a relatively modern approach for businesses which moves away from the linear take-make-waste approach, which the PMEM manufacturing process currently is, and aims to recover as much energy and material as possible in manufacture. The idea is to reduce, if not eliminate, waste, that once materials enter the cycle, it is difficult for them to leave as waste. It is based on the premise of having limited resources from our planet and how to effectively manage those resources, removing the concept of disposability, but in fact taking responsibility for our consumption. Since the 1960s, there have been several authors and thinkers who have built upon the premise of how to cycle Earth's natural resources. Subsequently, there are different approaches to the framework and indeed different terminology used throughout the last half-century. This has resulted in there being no one clear definition of the concept, and that in itself is posing an issue. Although the general consensus is on the same road, without a definitive definition, the concept is open to interpretation and misapplication. Another issue with circular economy, in my view, is that it is romanticised in a sense. It is to achieve perfection, which in honesty is probably out of reach for the foreseeable future, and almost certainly in the 25 years we have until the Scottish climate change target. Some authors tend to gloss over the implications of trying to implement their version of circular economy for businesses, and it is a bit of a chicken and egg conundrum between the likes of how to power your factory using solar panels and wind turbines, whilst the manufacture of these products themselves does not still fit with the circular economy ethos. This leads to the intention for my research. Initially, it was to try and fit the manufacture of PMEMs as closely as possible with the circular economy concept. However, I now think I'll be developing a stepping stone framework to allow for the realistic, attainable target to improve sustainability in this area, whilst also allowing it to apply to an alternative supply chain for PMEMs here in the UK. This framework will be specific to this sector, encouraging movement towards entire circularity. By doing so, our emissions are no longer consumption but are territorial, meaning we will be held more accountable for what we need, whilst also increasing our domestic manufacturing and processing sectors, not to mention the benefits to the environment. To achieve this, I've laid out 3 research objectives for the coming year. Firstly, to research current efforts relating to the recovery of end-of-life PMEM components and subsequent reuse, remanufacture and recycling methods for these parts. As previously mentioned, this I hope to conclude by the end of 2020. Secondly, to determine the potential viable solutions for PMEM components in line with the circular economy ethos. And thirdly, to develop a supply chain which could be implemented in the UK with novel approaches to the recovery and reuse of permanent magnet electric machine components, whilst fitting as closely as possible with the circular economy concept. Thank you for your attention.